Today we're talking about section 11.1. This is the chapter about rational expressions and equations. So rational, you kind of have to know, like rational numbers. It's talking about whether or not a number is able to be expressed as a fraction. Would be the best way to me to explain that. We've talked about it before. We talked about integers and real numbers and those kind of things. But for rational expressions and rational equations, we'll be basically expressing these as fractions, okay? It says a rational expression is a fraction whose denominator or numerator are both are composed of polynomials. So for this unit, instead of just doing fractions, we're incorporating polynomials. I know you've missed polynomials for a while. All right, so here we go. Just like we could reduce fractions to lowest terms, and we can multiply fractions, we can divide fractions, we can add fractions. In your book on page 406, they kind of are showing you a little just reminder about how to do those things. We recall that when you multiply or divide fractions, you don't need a common denominator, but when you add and subtract, you do need a common denominator, okay? We're going to be doing all these things with rational expressions, okay, which means fractions made of polynomials, okay? But today, we're going to talk a little bit about how to evaluate rational expressions. And we recall evaluating an expression just means finding the value, okay? So evaluate, find the value. This is example 11.1. 11.1a. And in order for us to evaluate, they have to tell us what values to plug in. So the original expression said negative 3x over x plus 9. The directions said evaluate the rational expression when x is equal to negative 2 and when x is equal to negative 3. So they're asking us two different questions. We'll do the first one. Let's evaluate it when x is equal to negative 2. So we're going to just simply replace all of the x's with negative 2. So instead of negative 3 times x, it's negative 3 times negative 2. And instead of x plus 9, it'll be negative 2 plus 9. Well, negative 3 times negative 2 is a positive 6. Negative 2 plus 9 is a positive 7 because opposites subtract. Voila. We just evaluated the rational expression. Okay? They'll tell you what values to plug in for the variables. Our job is to simplify it. Be very careful with the signs like negative and positive because, of course, that's always there to try and throw you off. Let's see. Another key point here is to understand that because we're dealing with fractions, we can run into what we call undefined fractions, okay? So this is a little reminder. Remember, a fraction like 1 over 0 is undefined. Anytime you have 0 in the denominator of a fraction, it is considered to be undefined. We talked about it's okay to have 0 on the top, like 0 over 1, that's just 0. But 1 over 0 is undefined. And we're going to be using that quite a bit in this unit because we have to be aware of any values that might give us a 0 in the denominator. All right, so for this example, they're going to kind of set us up a situation like this. They're giving us an expression, negative 2x over x plus 3, and they want us to evaluate it this time when x is equal to negative 3. So here we go, unsuspecting algebra student, we go in, we do, negative 2 times x, but we're going to plug in negative 3 instead, and then x plus 3, plug in negative 3 for the x, looks like this. Negative 2 times negative 3 is positive 6, no problem there, but negative 3 plus 3 equals 0. Anytime you work a problem, I don't care what the numerator says, if the denominator is 0, then your answer is undefined, okay? Anytime there's 0 in the denominator, it is undefined. So there are certain situations that we see here where you could have a value that would cause your answer to be undefined. We want to avoid this at all costs. We will be searching for what numbers will not work in an expression. And if it doesn't work because it would cause the denominator to be equal to 0. So the directions may say, determine the value that x cannot equal for the rational expression, okay? The numerator doesn't matter. It could be any number for the numerator. We are focused just on the denominator for those kind of questions. All right, scoop this up a little bit. This is example 11.1c. And this time, they're giving us the expression 2x plus 1 over 3x minus 5. But this time it didn't say evaluate. They didn't give us any numbers to plug in. They just want to know what values can x not be, okay? So we're trying to find the values that x cannot equal. Okay, so since that's the case, focusing on the denominator. I know that the only values x cannot be are the values that would cause this denominator to be equal to 0. So I'm going to just take that denominator and put it equal to 0. From there, I just solve for x. We get to dig out those algebra skills. We haven't used them in a little while since we had the graphing unit last. So to solve for x, we'll add 5 to both sides. So we have 3x is equal to 5. Last step, divide the 3 off to solve for x. So x is equal to 5 over 3. So we know that x, instead of equals, let me clean that up a little bit. Instead of x equals 5 over 3, we're saying that x cannot equal 5 over 3. Okay, it is the only value that x cannot be. It can be any other number, just not x equals 5 over 3. Okay? Thank you. Now, we've had better looking polynomials than that before. Let's look at a better looking one. This is just a simple binomial. Let's break out the larger ones. Here we go. Get a little more space on the board. Everybody got that? Good. All right. Here we go. Example 11.1d. We have x minus 3 in the numerator. And we have a quadratic expression. X squared plus 5x plus 6. And we want to figure out what x cannot equal. Determine the values that x cannot equal for the rational expression, okay? So again, we're just focused on the denominator. So I'm going to rewrite the denominator by itself. Equal to 0. And now we want to solve. But because we have the square in there, we can't just, get x to one side. We have a couple choices. We could factor this. We could use the quadratic formula, okay? Most of these that they're going to have you do for this unit are going to be factorable. You won't have to use the quadratic formula, okay, unless you're just stumped and you can't figure it out. So for these, let's just go right to factoring. I want to break this down. There's no GCF. Always look for that first. I know x squared would be x and x. And then factors of 6, that would add to give us 5. I know I've got 2 times 3, 1 times 6. Since everything's plus, I'm going to do 2 and 3. Because 2 plus 3 equals 5. So 2 and 3. My signs tell me that they're both going to be plus plus. Then we could check it to make sure. I know 2 times 3 is 6. 2 times x is 2x. X times 3 is 3x. Add those together. We confirm that we get 5x. So these are my 2 factors. But remember, we're trying to find out what x cannot equal. So what we're going to do is we're going to take these 2 answers, like we've done before, equal to 0, to help us find out what x cannot be, right? Like that's the purpose. But for now, we'll do it this way. So minus 2, minus 2. We know that x cannot equal negative 2. Minus 3, minus 3. We know that x cannot equal negative 3. So these are the 2 values that x cannot equal. Okay? All right. So this should be what you will need to complete today's assignment. Part of it will be just simplifying or evaluating, Well, they'll give you the values, you'll plug it in. The other part will be determining what values x cannot be. And again, we're just going to focus on the denominator.